Sorry.
So I don't know if you got a chance to catch up with the last one. It's fine.
Okay.
We'll just
No problem.
continue.
I can actually promise I will do it tonight. So I assign some time tonight to catch up.
That's good. So we finished Ethereum request for comment standards. You'll take a look at that when you catch up. So now we're looking at browser extensions. So basically, what the browser extensions do for Ethereum is they act as a client wallet, and they can also even interface with hardware wallets. They store your private keys, they store your public keys. Pretty much the biggest one is called MetaMask, and it allows your browser to act as an Ethereum wallet and also to gather information from the blockchain. And so this becomes really important or useful when we're dealing with dApps, which have front end user faces, because now if your browser has built-in functionality to draw data from the blockchain and send data with the blockchain, and you can use it as kind of like a GUI or a front end for your dApps, now you can do quite a lot of interesting things. Um, for example, you could potentially have a social media platform where the actual social media company owns absolutely none of the data of the customer. And once you would like to withdraw your data from the website, you would be able to do so directly from the browser because it's connected to Ethereum or whatever other blockchain. So it injects the Web3 API, the Ethereum Web3 API, into the JavaScript content of the website. The dApps are able to read web data and interface with the blockchain, helps you maintain your identity, has permission to read and write to every web page. The MetaMask extension does, and it acts as a cryptocurrency wallet. You can access your wallet through the browser extension. There's also a mobile app, a MetaMask mobile app. Stores your keys, broadcast transactions, send and receive tokens, allows you to securely connect to dApps. Then there's something called MetaMask swaps, which is an integrated service so you can exchange Ethereum tokens. And what it does is it puts together these things, decentralized exchanges. So these are just ways to purchase and sell various cryptocurrencies in a decentralized fashion. So ordinarily you have the big exchanges like Coinbase or whatever, and that's a very centralized way to either exchange cryptocurrencies or to purchase them using regular fiat currency. So they have these decentralized exchanges, and what MetaMask swaps does is it just basically aggregates them all together, helps you find the same best rate and charge a small transaction fee so that you can exchange currencies um, in a decentralized fashion, but also get the best rate out of the various exchanges. Any questions on this slide?
Um, it's like when you are talking about swaps, Ethereum. My understanding is Ethereum. It's a smart contract database. So when you are talking about swap, you are swapping contracts and you are not swapping Ethereum the currency. Do you?
So you would exchange. This is more for exchanging tokens. This is not for. So Ethereum has cryptocurrency. It has its own cryptocurrency, which is Ether, obviously. But these are exchanges between various currencies.
Okay, all right, thanks.
And it's built into the app and built into the browser.
Sure.
Does that make sense?
Yes.
Okay. So this is just showing you, this is what MetaMask looks like. Crypto wallet gateway to blockchain apps, buy, store, send, and swap tokens, so on and so forth. Token wallet, token exchange. So why is this relevant to Flow? Flow is trying to develop a more advanced version of this with the Flow wallet. So hypothetically, the Flow wallet, the end state of the Flow wallet should be able to aggregate every other kind of crypto wallet that you have. So you should be able to have a Flow wallet which simultaneously has Bitcoin, Ethereum, smart contracts, Flow, every potential kind of token or cryptocurrency in that one wallet, and then be able to interact with all those blockchains from a single place, where you having this wallet, having the public and private key of this one wallet stores all of your digital assets, which you will have direct ownership of. That kind of makes sense. So that's why this is kind of relevant, because this is like um an initial step towards Flow's end vision. So that's kind of why Flow is they see themselves as a Web 3.0 project.
It's actually very interesting because you mentioned that you may store multiple different kinds of cryptocurrencies in one wallet, but the wallet is the wallet on your local computer only, or is it some of it is also uploaded as a block, isn't it?
So are you talking about wallets in general, or are you talking about the Flow wallet?
So let's say I have a Flow wallet, and the Flow wallet contains Bitcoin, and the Flow wallet contains, I don't know, whatever else cryptocurrency there is there, something that you can buy on Coinbase, Ether. And then, if both of those will be basically two private keys.
Yep.
Do you store that private key in your browser, or do you store that private key in the Flow network as a block?
So what I would imagine is your Flow public and private key would be stored locally or wherever you would store it.
Okay.
And then you couldn't have the other public and private keys, like the one for Bitcoin or blockchain. You couldn't just store it on a block, because then it would be, your private key would be accessible for everybody.
Exactly.
So I'm not sure exactly how it works, but what I would imagine is that since Flow uses off-chain data, I don't think that you would need to store the public and the private key separately. Probably what you would do is when you send Bitcoin to a Flow wallet, for example, then it would put that off-chain transaction, register it on the Flow blockchain, and then when you use your Flow wallet, then it would boot up whatever private keys that you have and then be able to access it. So the transaction, I think, would be stored on chain, not so much the public key and the private key.
Okay, I understand.
I don't know if that made any sense what I said.
Kind of makes sense. I see some issues with it because you can go out of sync with your main cryptocurrency account, but I don't want to go into that question because in details now, because it probably takes too long. We can
I don't think I understand the wallet that much to even engage you with regards to that. And I actually don't think it's at that level of maturity yet.
Mm-hmm.
I think it's still very much still being developed for that functionality. That's more like the end. That's their final vision. I'm not sure that they really have all these details ironed out. So the next thing we're going to talk about something called Chainlink. So I don't know if you got a chance to take a look at what the oracles are in one of the previous ones. But basically, oracles are just smart contracts that continuously get real world data and is stored on the blockchain for ease of use. So what Chainlink is a decentralized Oracle network, which is based on Ethereum. And it makes it easier to get that tamper-proof data and to feed it to on-chain smart contracts. So why is Chainlink relevant? So you have the oracles, which can get off-chain data, and they kind of act like APIs for data which needs to be on the network. But the problem with them is that, and this is called the Oracle problem, that if, let's say, the data that the Oracle is drawing from is illegitimate, then now you have illegitimate data which is being trusted on the blockchain. So that's kind of what Chainlink tries to solve by being a decentralized Oracle network, specifically for oracles. And it verifies the parameters for contracts that independent stakeholders have. So like, let's say I have an options contract on the blockchain, which has to execute at a particular strike price. If you only have one oracle, it's technically possible to like poison the source of information that the oracle is receiving and then falsely execute that smart contract and then immutably have somebody lose a significant amount of funds. But if you have an Oracle network, which in itself is decentralized and self-checking and is getting the data from multiple sources, and each Oracle is validating itself, then it becomes a lot more secure. So the way that Chainlink works is that actually it has its own cryptocurrency called link. And people that operate nodes on Chainlink are compensated by getting link. And it's used for various off-chain computation, VRF, verifiable random functions, data feeds. It's even been used in elections. It can be used for random number generation, which is obviously important for decentralized gaming, but it also makes sure that the in-game results are tamper-proof. So its token is an ERC677 token, which is an extension of the ERC20 token, and it can have data in it. And then trade value of link is used to pay node operators for retrieving data from smart contracts. Deposits placed by node operators as required by contract creators can be stored in any ERC20 compatible wallet, and it has all the function of ERC20. So I don't know how far you got into oracles, but this is basically creating a different blockchain using specifically oracles in order to supplement Ethereum.
It makes sense in general.
Okay.
It probably has
Are
the
there
same
any
issue.
specifics that don't make sense? Huh?
It has the same issue what you mentioned before, that if the offline data or if the offline data or the off-chain data is compromised early and you bring it on chain, might be an issue. But it makes sense, yes.
But the way that this is trying to circumvent that is by having multiple oracles draw the same data from different sources, and then they validate each other. So that's kind of how they try to. It's not perfect, but it's a solution. Okay, so this is what you can go on Chainlink and see what it looks like. So you can see there's a section for developers that want to do smart contracts that interface with Chainlink. You see market and data feeds, VRF, random number generator for blockchain gaming, NFTs, automation for smart contracts, so on and so forth. So this is something that will probably be useful for Cadence in the future. Cadence is not really at a level of maturity to be interfacing with something like this, but I can imagine that they have either they're going to use oracles or something similar to oracles, or maybe just use Ethereum oracles or something like that. So there's some relevance here for Cadence in terms of the future. We've already done the slide. Do you have any just general questions about Ethereum or blockchain security?
No, not right now. It's kind of like makes sense, that part. Says most algorithms have been around for quite a while, so it's quite straightforward.
Okay, great. So now we're going to look at some utilities and use cases. We're going to look at smart contracts, dApps, some comparisons, and that's it. We're done. So let's look at smart contracts. So a smart contract is just basically a piece of code. It's a contract which is published on a blockchain and it has individual parties. So obviously the individual parties to a blockchain contract are public keys, public key addresses, which represent wallets, which represent owners. And then usually a smart contract is basically like a logic bomb. There's some kind of a triggering event, there's some kind of expiration date or strike price, which causes it to execute. Some of the benefits to it is that you can't censor smart contract so long as the code is valid and it will run. You can't really stop it. It prevents against fraud because obviously if it's on the blockchain, anybody can read it and see what's in it. There's no downtime so long as the entire network is up. And it's not open to interpretation because it automatically self-executes. So it's code, it's computer code, which facilitates, executes, and enforces negotiation or performance of agreed upon terms. It's automated. Consensual exchange of items of value. There's no middleman. There's no need for legal language. It's very lex mercatoria, or very laissez-faire. It's entirely digital and it's written in programming languages. So you could write in Solidity, which is for Ethereum, C++, Go, Python, Java, so on and so forth. Obviously, Cadence. It defines the rules and the consequences, the obligations and penalties. So it's written, you code it. On Ethereum, it's written in Solidity. On Flow, it's written in cadence. It's put up on the ledger, and then it's executed. When it's executed, the nodes agree to the results, and the network ledgers update that to record execution. Any questions?
Well, I think it makes sense.
So what is a DApp? Basically, what a DApp is a smart contract with a front-end interface. That's basically what a DApp is. So a DApp is an application which is built on a decentralized network. It's a decentralized application. And it takes a smart contract, but it just adds a GUI to it or some other kind of front-end user interface like a CLI or something. So smart contracts are transparent. They're on the blockchain. They're almost similar to an open API. And one DApp could use multiple smart contracts or even other people's smart contracts. For example, an Oracle. So let's say I had a gambling DApp. I had a DApp where you could put in votes for what team you think is going to win. That DApp could then reference a smart contract, which is an Oracle, which is getting off-chain data as to the outcomes of a sporting event, which will then feed it into my DApp. So the backend code runs on the decentralized P2P blockchain, whatever blockchain that it's on. There's no centralized servers. And the front end code and the user interfaces can be in any language. It makes calls to the backend. And you could even host the front end in a decentralized way, like putting it on IPFS or something. So that means no one person or group has control over a DApp once it's published. They're deterministic. They perform the same function regardless of the execution environment. They're Turing complete. They can perform any action if they're given the right resources. They're isolated. They're executed in the Ethereum virtual machine. And so what that means is if there's a bug or like an overflow in a DApp, then it can't affect the rest of the blockchain functioning because it's in the EVM. It also means that there's no downtime because since it's deployed over the entire network, it's always able to serve a client. And it also means that you can't really launch a DOS attack, a denial of service attack against a particular app. There's privacy because you don't have to put your real world identity to deploy or work on dApps or to read or to interact with one. It's resistant to censorship. Nobody can really stop you from submitting a transaction or deploying dApp or reading data. It has complete data integrity. It's immutable. Malicious actors can't forge transactions of the data. And this trustless computation and verifiable behavior, smart contracts can be analyzed and guaranteed to execute. So some of the flaws of dApps and smart contracts is that on Ethereum, once you publish it, it can't be changed. So that's what the test nets are kind of for. So you can kind of test out your scripts. But if there is a flaw that you didn't see, or for example, doesn't execute properly, then there's nothing you can really do about that. In Flow, you can actually put a beta version of a smart contract or a dApp, and then you have a certain time period where you can update it and put a final version. So you do get a little test window on the main net, which doesn't exist on Ethereum.
Yes, that kind of makes sense. So I have a quick question. So it's like based on testnet and mainnet. So is mainnet connected to the global online flow blockchain?
Mainnet is the blockchain.
Okay, so that's the live database, isn't it? Okay.
Yep. Well, but for Flow, it's not just a database; it's also a computation engine.
Yes.
And all the other stuff. You had a question about testnet?
No. It was just so that I completely understand. You know the differences between mainnet, testnet, and localnet. So basically, mainnet and testnet are the production code, and then testnet is just some sandbox, and then obviously localnet is non-production code and just something locally built, and obviously non-production data as well.
Yep. And testnet, so there's two testnets to Flow. One of them is run by Dapper themselves. So I don't know if they use cloud instances or what they do, but one testnet is run by Dapper, and then there's another testnet which is run by a different business, which is called Canary Net.
I see.
And then there's local net, and then there's the emulator, which it kind of lets you like play around with the CLI and stuff.
Oh, yes. And I forgot to mention, we also need to update later the emulator code base to support the observer.
Oh yeah. Yeah, you might want to jot that down somewhere so we don't forget to do that. So here's just a comparison of Ethereum and Flow. So throughput, cost, energy, and ecosystem impact. Oh, that's not ecosystem impact. That's just the general ecosystem. So the average block time in Ethereum is 13 seconds. Flow is 3 seconds. The average transaction per second in Ethereum is 17. On Flow, it's 100. On Bitcoin, it's like 3, I think. The average transaction fee in Ethereum is about $22. I didn't even realize it was that high. On Flow, there is no transaction fee. The annual energy cost of Ethereum is about 2.7 billion. On Flow, it's about 4.2 thousand. Obviously, that's going to raise up as Flow expands, but it is better for the environment.
That's huge.
Yeah. The energy is annual energy consumption. Ethereum has 53.77 terawatts. I think that's what that is. I don't even know what that is, man. I think it's terawatts.
It's terawatt hour. So that means that 1 year has about 10,000 hours. So if you divide that by 10,000, that's 5.3 gigawatts. It's a 5 gigawatt power plant that's needed to power this thing.
It's crazy. On Flow, it's 0.08 gigawatts per hour. So significantly less. CO2 output per transaction, 48.4 kilograms of CO2. On Flow, it's 0.001 grams of CO2. The ecosystem, so I would have chosen a different word besides the ecosystem, but like the environment, top NFT DApp ranking. So Ethereum has number 2, which is CryptoPunks, which has a 340 million volume, and Flow currently has the number 1 NFT DApp, which is NBA Top Shot, which has a $570 million volume. Ease of development. So this is kind of subjective, but they say that it's hard on Ethereum and easy on Flow. Obviously, this is like Flow marketing stuff. So it needs a little bit of salt, a little grain of salt. That's it. Any final questions?
Thank you.
So you are now an expert on Ethereum as well?
Pardon me?
You're now an expert on Ethereum as well?
Thanks. So it's so here is the thing that is very interesting. It's more like a discussion rather than a specific question. If you think about it, what is value in a blockchain? So let's say how you would store, for example, the transactions and the data in the bank for a town in Nevada, let's say, or but wherever, like a small town. Then you really think about it two ways. So all these transactions that we have and the consensus, what it says is that, okay, we have a set of transactions and we have a state of the financial ecosystem that is approved and signed by, let's say, 100 different computers. And the way those 100 different computers sign it is in a way that, they basically generate these hashes, and then they verify whether they come into the same conclusion, and then eventually that they approve and accept this consensus. And the way they do this is that, they do computation. That's the whole thing is about. And that has two implications. It's partly one of my blog items that I wrote a while ago. That it has two implications. So what a consensus node does is that it basically does two things. One is that it generates a salt or an initialization vector, whatever algorithm you use. And the other one is that it does a bunch of computations on top of that, which is either an elliptic or a polynomial algorithm, which, it's basically heavy computation. And the reason why you are doing that, in order to have a consensus that, let's say, is indeed covered by 5 gigawatts of energy, in which case you can say, okay, if 5 gigawatts of energy says, okay, you have this amount of money, then nobody else can compete with you because you have the 5 gigawatts of energy. And what this implies is that blockchain by nature, the blockchain algorithm, the consensus algorithm, is a monopolistic algorithm. So that's my main concern with it, is that you cannot just easily create another one, because in case, let's say, you have Bitcoin, you will create someone else, let's say Ethereum, and then Ethereum will compete for the same power plants. So eventually what will happen is that those actors who want to do a foul play, let's say, malware, hackers, etc., they will try to let people use as many cryptocurrencies as possible so that those gigawatts go down that do the consensus, and they can stick in their own solutions so that, in certain cases, in certain situations, they can inject their own bad things into that blockchain, which means to me that the whole thing is about electric power. Mm-hmm. And it's by nature monopolistic. So eventually the main blockchain will be a monopolistic provider, because they will be so reliable that nobody else can compete with their processing power. On the other hand, this processing power can be used for many other things. So the only way you can leverage this blockchain thing is that you basically heat houses with it, so that people don't complain that it's not me.
I think that you have a really interesting thought. I never looked at it that way, that basically when you boil it down, it's a game of electricity, and yes, who has access to the most electricity. And if you wanted an attack vector, obviously it's very difficult to attack it from a software perspective, but you could manipulate power sources, and that could affect consensus and stuff like that. Heating houses, I've heard about that though. That's a common way to.
It makes sense, actually.
It does. That's a really interesting idea. Let me think a little bit more about that, because I've never heard it broken down from that perspective. But then somebody could argue, well, isn't that true of the entire financial system? That it's based on access to power, but the power that they have access to would be more centralized power now, and that this one is decentralized. Because if you're going to pick a bank, you only have so many banks that you're going to pick from. Yes, and that's because right. of regulations, but also because of, I guess it's not only power, but their reliability and access to hardware. It does affect it as well. Let me think about it so I can give you a more like sophisticated thought about it. But it's a very interesting thought. I've never heard anybody have that perspective.
The banking system is different in the sense that their income is not the deposit. So in case of blockchain, there is no credit, it's a deposit, and you make money on basically taxing the deposits. And then in case of the banking system, they provide loans and credit that makes the economy working. So when you have a company and you have trucks or bulldozers, you replace those bulldozers time to time when they depreciate and they amortize. And basically, those you need to have many banks in order to cover the whole industry, so that everybody gets the loan they require to run the